solving linear systems by using the method of elimination. So what the method of elimination is, it's basically, it allows us to solve a linear system by adding or subtracting one of the variables. Right? You may want to write this down, pause the video. Once again, it allows us to solve a linear system by adding or subtracting one of the variables. Now, this will make a lot more sense if we start looking at an example. Right? But before we look at the example, I just want to review quickly what exactly is it that we're doing when we're solving linear systems. Recall that when we solve linear systems, we're essentially finding out the point of intersection. Now we can do this graphically, so if they give us the equation of the lines, we can find the point of intersection graphically, but we can also do this algebraically. We learned previously that we can use the method of substitution, and now we can look at an example of using the method of elimination. So it says, example 1. Solve the system of linear equations. Check your solution. Okay, let's begin with this. So we have 3x plus y equals 19. And we also have another equation, a linear equation, 4x minus y equals 2. So the first thing I suggest, just like before, label the equation. So let's call this equation 1, and we're going to call this equation 2. So as the definition said, you solve it by adding or subtracting one of the variables. Yeah. So the main goal really is to try to eliminate one of the variables by either adding or subtracting. Now here, if we add these two, 3x plus 4x, that gives us 7, so we cannot eliminate anything. And if we subtract 3x minus 4x, we get minus 1x. So fine, that doesn't work. How about here? If we add y plus minus y, then we're going to get 0y, or essentially 0. So we can use addition here to eliminate them. Right? So what we're going to do is the following. We're going to add these two equations in order to eliminate the y variable. Once we eliminate the y variable, we can find out what x is, and once we have the value of x, we can substitute it back into either one of these equations to find out what y is. So first, let's add these equations. So in order to eliminate y, so you add equation 1 plus equation 2. What is this going to give us? Well, 3x plus 4x, that's equal to 7x, plus, and remember here, there's a coefficient of 1, right? Plus 1y minus 1y, that gives us 0y. Right? I don't need to write that down, but just to show you what's going on. And now we're adding 19 plus 2, that gives us 21. Alright, so now we're left with 7x equals 21. So now we can solve for x. So solve for x at this point. So that means x is equal to 3, right? Because 21 divided by 7, and x is equal to 3. Now that we have x, we substitute x equals 3 into one of these equations in order to solve for y. So just like before, choose one of the equations, right? So let me just emphasize this. Make sure you guys take notes. As you know, you can always pause the video, maybe try the question yourself, right? So substitute x equals 3 into equation 1. So let's do that. Equation 1 is 3x plus 1y equals 19. So let's do that. So we're going to get 3 times, so this is 3x plus 1y equals 19. Okay, now let's solve for y. So we already have x equals 3. That's the x-coordinate of the point of intersection. Now we need to find the coordinate of y. So 3 times 3 gives us 9, plus 1y equals 19, and we can move the 9 to the other side, so this becomes y equals 19 minus 9. Y is equal to 10. So we found out what the point of intersection is, and according to this, the coordinates are going to be, our point of intersection is 3, 10, right? 3, 10. And of course, as I said before, you can do this graphically, but if they ask you to do it algebraically, this is the method, using the method of elimination. Now, you can use Decimals, which is a graphing tool, and I'll be providing the link right below, to graph these two equations, but just to show you a rough sketch, this means that algebraically we found what the point of intersection is, 3, 10, and if we were to graph these, essentially I believe we would have something that looks like this. This would be our equation 1, just a rough sketch. As I said before, you can put this, right? This would be our 19, etc. And our equation 2 would be, I believe, this way, right? So once again, this would be our equation 1, which is 3x plus y equals 19, and this would be our equation 2, 4x minus y equals 2, right? And they meet at this point, and this point would be our point of intersection, and the coordinates of that would be 3,